Okay, welcome back. So I've just got a new notebook here. I'm going to do some copy pasting and organize some stuff. I've got some of the imports up top already. So we're going to create a linear regression class. So for any object here, we initialize, we have our self. I think the only things that I'm really thinking about that would be natural to pass through here are possibly just the number of iterations that you want to do when you set up your object. So we can do num iter. Let's default it to 10,000 like we had before. 10,000 that we had before, and then I'm going to say h equals 0.001, not 2, 1, as the default here. And so self.num iter then is going to be just equal to the input that we have for num iter, so number of iterations. Self.h for our step size then is just going to be equal to h. And then let's go ahead and set up the parameters. Self.PERAM parameters as an empty array for now. Okay. And then let's go ahead and initialize our parameters. So to initialize the parameters here, we just need the input. Future is x, like we had before. And so I'm going to go ahead and roll over here, copy a couple things here, and then change them carefully. Copy, paste here. Try to fix my tabbing right away. So num rows, num columns equal x.shape. That should be fine. Now it's self.parameters. Self.parameters equals numpy zeros, calls 1 should be good. Update self.parameters here equals self.parameters, reshape self.parameters. And then return all these returns here. We will return an instance of the object itself. Looks good. Yeah, I think that's good. For the gradient descent here, again, more or less a lot of the same stuff that we had before, so that we can just kind of copy and paste. So let's go to our gradient descent. We'll copy this for now. Paste that. Fix this indentation. Okay, so gradient descent. What do we want to input in for our gradient descent? So we need the x and we need the y. And then originally we had num iter and h, but we have that as an attribute of self, so I don't need to pass that through. I can access it in here anyways. So new x equals x.assign. That looks good. It says, you see the squiggly here is telling me I gotta change this. So now I've got self.parameters. Looks good. Extract the number of columns and rows, x.shape for I in range. Now self.num iter. UX. W is defined inside this function, so I don't need self.w. That looks good. The gradient looks good, so now we're going to update our parameters. H squiggle line self.h times dldw and return not just w. Let's see here. How do I want to do this? I want to send back my final parameters. So let me just add in outside of the loop now. Self.parameters, reassign that to be, so take my final w from my loop, send that in the back as self.parameters, so then it just returns self, and now that gets updated. That looks good. Define training the model. Okay, so training we just kind of did in a couple lines of code in the original, a couple cells of code in the original notebook. I don't think that we actually wrote a function for it. So let's go ahead and do that here. So to train the model, you want your x input data and your y input data. And then to do the actual training, I'm going to first initialize the parameters. So self dot initialize parameters, and we initialize parameters based on x. So now it's going to access this function in here. That looks good, and that returns an instant of self. And then we can run the gradient descent, self dot gradient descent, and we will use x and y to do that. That will be good, and we will return an instance of self. So that will do the training model, and I think that's what we have there. To go ahead and print the coefficients, I don't need anything other than to access the final parameters. So we're not going to access this method here until after we've done the training. But with that, let's go ahead and we wrote a loop for that. Down here, everything was called this W vector. So rather than having to rechange everything, I will just add a line at the start of this. So first of all, let's get this indented here carefully. So for I in range length W vector, just want to check my indenting here. If I, that looks good. That looks good. So else is lined up there. That looks good. This shouldn't be in there. Okay, that looks good. So then now it's ticking in self. So all I gotta do is assign the new parameters to this thing called W vector. So W vector is equal to self dot parameters. There we go. So this takes it in. After you train the model, your parameters are updated. Put it in the W vector. And then I can run the print statement. I don't need to return anything. It's just actually going to print those items. So that looks good. And then the last one we have here is I want to just define a prediction method. And for predicting, I just need the test data that I don't already have access to from my instance of self, because I can get my updated values from my parameters there. So let's see here. We did that over here. Oh, we actually kind of already did this. So let's go ahead and just copy this and paste that. And so that's where I want my indenting. Self, and it takes in x test. So new x test is x test.assign the constant. That's good. W is now self.parameters. That looks good. Predicted values, np new x test and w. That's good. Let's get this return in the right spot. I don't want to return. I do want to return predicted values, don't I? That looks good. What's wrong with this right here? Oh, it's got to be inside our function. Indentation there, and that looks good. Okay. I think we have everything we need here to create our class objects. Let's go ahead and run this, see what errors we get. No errors yet. Well, let's go ahead and copy and paste. I'll probably fast forward this here. Copy and paste the data setup that we had at the start from the last notebook that we know what the coefficient should be. And we'll go ahead and see if we get the same results when we run it this way. Okay, so I've got all that stuff kind of copy and paste that we had from before. So now let's go ahead and access our linear regression class and just see if this works. So I'm going to go ahead and say my model then is equal to an instance of my linear regression. Okay. And what I want to do here is I want to train a linear regression model. So I'm going to access my train function. So model.train that we defined here. And the train function is going to take in, what did we say? It just takes in our x and y now. So we're going to go ahead and train it based on the x train from our split and the y train from our split. And we'll go ahead and see how long this takes to run now. Okay, looks like it's trained it there, about 8 seconds. Let's see what we get. Moment of truth. What are the coefficients? Model.print coefficients. Just run it. 0.992206 and negative 0.06069. Is that what we had before? Yes! Booyakasha! All right, awesome. So we defined our class, this object, and it works nicely. So if we want to do prediction values then, we could essentially do the same thing that we had before. So I can do, I'll save it as predicted values. And now we just got to tell the model to do the prediction. So model.predict. And we go ahead and input x test here. There we go. I'll let that run. And if I did that, the same thing over here, we can do a scatter plot of our prediction values as well real quick right here. Yes, the prediction looks like it worked too. That's awesome. Good, 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 good. So we've successfully done our class there. But question of interest then is this robust enough to work on more than one predictor, right? So if you typically pull something in, like you have a pandas data frame and you maybe grab your inputs, maybe you have features x1, x2, x3, and x4, right? Let's see, does that work here? Does it work with more than one predictor or feature? Let's find out. Okay, so I need a new data frame now that has 2 predictions in it. So let's go ahead and set this up. So I'm going to say x is going to be equal to 5. Again, kind of going in circles here, but just to sort of set something up to mimic the workflow where you typically start with a pandas data frame. So now I've got x1 here. Let's add an x2. And that's just going to be the x2 column or piece of information I had there. Comma. So my data x1 is x, x2 is x2, y is coming from y. Let's just change this a little bit here, and just so I don't overwrite anything on accident earlier in my notebook. So I'll say d panda pd.dataframe da, and then I will take a look at the first few rows here, just so we can see that quadratic relationship. So the square of 3.39 is 11.4. That looks good. And there are the y values that I have with that. Okay, that looks good. Let's get ready to do the train test split like we would want to do before. So I'll copy this down here. So we don't overfit our data. Just gonna go ahead and copy that too as well down here. So let's say you do some exploratory analysis and you're like, okay, I want to do features x1 and x2 to do, there's a linear relationship there with y. So my inputs x, I gotta update, this is coming from DA here. I want to do x1 and x2 as my input for my linear model there. DA right there for my target y. And then I don't think I need to change anything else. Inputs x, target y. Test size of 25% is fine. I'll train on 75% of the data. Random state right now, I'm just doing that just so if you're following along, you should get the same numbers. Let's just go ahead and run that set up there. Okay, so now the moment of truth. Does our linear regression class work? Now we have 2 inputs on our inputs, our x train, right? So because x train is splitting up both columns here, right? It's just taking a random selection of rows. So we'll do model, again, is equal to my linear regression. And then we'll do model.train with x train now and y train here. And let's give her a whirl. I'll get ready here. It's done. Okay, good. So I'll do model.print underscore coefficients. Print underscore coefficients. Let's see what we get here for coefficients. 1.01, 0.08. Look, all the print function worked nicely, even though we added an extra w to this. And our intercept at negative 0.3. All right, is this good? Let's compare. Let's compare against the sklearn version that we have here, right? So for sklearn, their regression model is just called linear regression. And what do we have here for coefficients? 1.1, negative 0.03. Okay, we're a little bit off here. We are a little bit off. So this could be, if we think back to the mathematics, we could have, we needed to move more iterations to converge or change our step size. We don't have any sort of function in here actually on checking for convergence. So this is something you could do. Now that you have this class here, you could go ahead and add a function, you know, and check the loss. Actually, you'd want to do this inside probably your gradient descent here to know how many iterations you'd want to do to converge, right? So for now, I'm just going to go ahead and see if I change the number of iterations that I want to do. So when I pull up my model, I'm going to say, let's just run, instead of running 10,000, let's just run 75,000 iterations and see what we get here. There we go. And the coefficients now, 1.24, 3168, and negative 0.03109, negative 0.5525. So basically the 3 or 4 decimal places, we've got it correct. Awesome. So we could change the step size. We could try 100,000 iterations if we wanted to, right? Just to kind of guess and check and get there, right? Also, though, we could just go back. A more sophisticated way would be to, you know, think about, we haven't covered the math on looking for when it would be considered converging, but we could think about how we could do that, and then we can add that into our class right here. This is good enough for me, though. I'm excited. It worked with 2 parameters, no problem, so I'm hoping we could add a third. Who knows? I think I'm pretty excited with that. So I'm going to go ahead and maybe comment this out a little bit more, this class right here, this object, and clean this up a little bit, maybe upload it to GitHub or whatever. But now we have a starting block, and we can always build upon this. And I hopefully you get a sense of appreciation how nice it is to have some of these things. Like, again, setting up this training, it took, how long did that take? 0 seconds. I don't know. It's less than 1 second for it to run this. So they've got some things figured out. That's really cool. So I'll probably be using that when I'm doing work on my own, but I think we have a better understanding of what's going on behind the scenes.